everybody. This is a really fun lab. This is the pre-lab for the surface area to volume ratio lab. So just a little background information. What's the surface area to volume ratio? A surface area to volume ratio is basically just the surface area of an object divided by its volume. So for example, if you have a cube and the cube has sides length d, then if you take the surface area of a cube, each face has an area of d squared, and there's 6 faces of the cube, so the total surface area of a cube is 6d squared. And of course the volume of a cube is d cubed. So if you take 6d squared and divide it by d cubed, the surface area to volume ratio is 6 over d. Now, as you can see here from this relationship, the smaller an object is, in other words, the smaller d is, then the larger the surface area to volume ratio is. And this phenomenon causes a lot of interesting changes in nanoparticles compared to macroscale particles. So, for example, some of the things that can change as the surface area to volume ratio changes are chemical reactivity, melting temperatures, electrical conductivities, thermal conductivities, and even some tensile properties and mechanical properties. Now, this week's lab is supposed to illustrate the importance of surface area to volume ratio by examining the rates of chemical reactions for smaller particles as opposed to larger particles. And of course the smaller particles should have a much larger surface area to volume ratio. The first demonstration of this is the Alka-Seltzer demonstration, where you take an Alka-Seltzer and you compare how fast the Alka-Seltzer dissolves in solution when it's a whole Alka-Seltzer versus one in chunks versus a powder, and you time each one of those things. And then another one, which another demonstration or lab, which is a little bit more involved, which uses agar cubes, and that models cells, and it shows how the larger surface area to volume ratio for smaller cubes causes a different rate of diffusion for the particle. Okay, and this has important implications for sizes and dimensions of cells. So for these things, I would like it if you would partner up, work in groups of 2 or so folks, and of course if we have an odd number, a group of 3 is fine too. So as I said, for the Alka-Seltzer, you're going to be given a stopwatch, or you can use your phone, that's fine too, and compare the amount of time that it takes to dissolve an Alka-Seltzer tablet that's whole, broken into 3 or 4 large chunks, and then ground in a powder. There's more explicit instructions in the lab handout that you'll be provided. Now when you're done with this lab, it's just Alka-Seltzer and water. You can pour the used solution in the sink. Just don't be silly, and don't eat the Alka-Seltzer or drink the Alka-Seltzer solution. Don't inhale the powder, and I'm not going to require any protective gear for this lab. When you're done, make sure to clean up after yourself. Throw away all the Alka-Seltzer wrappers, recycle any disposable cups when you're done, and if you've used glassware instead of disposable cups, please wash it. The agar cubes, I've already prepared an agar sheet that's been doped with phenolphthalein, which is a pH indicator. The agar sheet doped with phenolphthalein looks kind of like gross jello. It's sort of this, I don't know, off-white color, and it's in a big metal tray. Now you're going to cut rectangular solids out of this agar sheet. In the lab it says to cut cubes, but I wasn't able to make a sheet that was 3 centimeters thick. So just go ahead and do your best to make the length and the width of the little rectangular solids 3 by 3 centimeters, 2 centimeters by 2 centimeters, and 1 centimeter by 1 centimeter to kind of simulate, small, medium, and large objects. And of course, as you go down in size, you should have a larger surface area to volume ratio. And then what you're going to do is while you're cutting them, and then once you cut them, make sure to carefully measure them with supplied rulers so you can calculate the surface area to volume ratio. Once you have your agar cubes, you should prepare a solution of 50% water to Windex, and then you're going to submerge your agar cubes in this solution for 10 minutes. You can use either your phone or the provided stopwatch for the timer. Now Windex contains ammonia. It's a household cleanser that contains ammonia, and ammonia is a base. And so with the agar cubes, which have been doped with a phenolphthalein, which is a pH indicator, the cubes should turn from that off-white color into a pink color, okay, as time goes on. I provided a link so that if you want to learn more about phenolphthalein or agar, you can read up on them on As You Learn. Okay? Now what will happen is it'll turn pink slowly. So it'll start at the most outer part and then diffuse in. So once the 10 minutes are up, especially on the large cube, you should be able to, at the end of the 10 minutes, take the agar cubes out of the solution, dry them gently, dab them dry with a paper towel, and then you can cut into them with a knife and see how far in the agar cube the ammonia was able to diffuse. So it should look like there's a little white rectangle in the center of a pink rectangle when you cut into your agar cube, especially the largest one. When you do this, make sure to take pictures and measurements as described in the lab report. All right? When you're done, you can pour your Windex solution down the drain and you can throw the agar cubes in the trash. Don't be silly. Don't drink the Windex. Don't get Windex in your eyes. If something does happen, just flush with water, and don't eat the agar. Okay? So this is a very safe lab, and you're only going to hurt yourself if you're being silly. So agar comes from the cell walls of some types of algae. It's an ingredient in some foods, and it's also a vegan substitute for gelatin. That doesn't mean that the agar solution, the agar sheet that I have prepared, should be consumed in any way, shape, or form, because I've added phenolphthalein to it, which is a mild acid and which isn't edible. Okay? So don't eat the agar to see what it tastes like. Just don't be silly. Windex is a household cleanser. And if you've ever done this, if you've ever gotten Windex in an open cut or gotten it in your eyes, you know that it can burn your eyes, it burns in a cut, and it can dry your skin. So don't do anything like that. Use a spoon to get the agar cubes out of the beaker after your 10 minutes are up. I've provided some disposable spoons. When you're done with the disposable spoons, don't throw those away. Wash them off and set them to the side because we might want to use them again for something else. Alka-Seltzer is a painkiller and it helps settle the stomach, but don't consume the Alka-Seltzer in today's lab. So make sure to just pour anything that you're not using down the drain and throw away the agar cubes. And phenolphthalein is a mild acid, but it's very dilute in this lab anyway, and so you should be super safe with this. So wash the glassware when you're done, clean up after yourself, and have fun with it, Let me know if you have any questions, and I'll see you around.